Pre-Calculus, Chapter 2, Lesson 4, looking at real zeros of polynomial functions. In the last video, we looked at the rational zero theorem, which allowed us to make a list of the potential rational zeros of the polynomial function. Well, what we want to do now is, how do we take this list of possible or potential real zeros and figure out which ones actually are? Now, we're going to do this in a couple ways. Well, actually, we're going to do it in one way, but I'm going to explain a couple things. If you didn't have a calculator, if you were taking a test where you didn't have the access to a calculator, you were not allowed use of a calculator, you would then take this potential list and use the remainder theorem that we did in the previous videos to determine which one of these potential zeros is actually a zero. And you remember, with the remainder theorem, you would simply take each one of these values, substitute them into the polynomial expression, and simplify it. And if you got a 0 as a simplified number, then that's going to be the remainder, which means when you divided, it would come out evenly. And if it comes out evenly, it is a factor, and then the factor, you remember, gives us the zeros. So if you didn't have a calculator where you were able to, or use a graphing calculator, you would take each value that you have in your list, substitute it into the expression, and find out which one is simplified to 0, if any. Any of them that would simplify to 0 would be a 0 then of the polynomial function. So you could use the remainder theorem from this list. The second way you could do it without using the remainder theorem, if you forgot, would be to synthetically divide this polynomial by each one of these values and see which one gave you a remainder of 0. So you would do synthetic division using 1, synthetic division using -1 or -1, and then synthetically divide by half and -1/2, and you would do each one until you determine which one gave you a remainder of 0. Any one that gave you a remainder of 0 would be a 0 of the polynomial function. So that's a second way to do it. A third way to do it, and this is the way we're going to do it, is rather than have you use the remainder theorem for every single value or synthetically divide every single value, I'm going to allow you to use your calculator to narrow this list down even more. But please make an important note of this. You cannot use or should not use your calculator to calculate what the 0 actually is. This is not the point of this exercise. The point of this exercise is to determine the zeros algebraically by hand without the use of a graphing calculator. So that's the process you need to understand. All I'm doing is allowing you to use your graphing calculator to narrow this list down, so it's kind of a little shortcut rather than having to do the remainder theorem for every value or synthetically divide every value. Okay, and here's how I'm going to allow you, or here's how you can use your calculator to help you out. So let me give you this example right here. Oops, wrong button. Okay, so what I've done here is I've graphed the expression 6x cubed minus 5x minus 1, and here's the graph, and I have my list of potential zeros here. So what you can use your calculator for is to look where this graph crosses or touches the x-axis, because those are the zeros, and determine if any of these numbers are in your list of potential zeros. Okay, so if we look at this value right here, this is somewhere between 0 and 1. I'm not really sure what it is. It looks like it might be, 2/3 or something, but as I look in my list here, 2/3, that number is not in my list anywhere, so that's not going to be a rational 0. Now this one looks like -1/3, which could be in my list. I mean, -1/3 is in my list, so that might be one of my zeros. So I might want to just mentally note, okay, -1/3 looks like that could be where it crosses the axis here. Here, it looks like it crosses at 1, and again, I want to check and see, is that number in my list? And the positive 1 is in my list. So what I've done is use my calculator to take my list of possible zeros and narrow it down to the two most likely candidates that I can see by using the graph. Okay, now again, do not use your calculator here to actually calculate the 0. We know you can do that. We know that's possible, but that's not the point of the exercise. So now what I can do is I can either use the remainder theorem, substitute each one of these numbers into the expression, and see if they do give me a remainder of 0. and in that way I could determine which one is a 0. What I want you to do is confirm it by using synthetic division. So I want you to synthetically divide each one of these zeros that you think is a 0 to actually confirm that it is a 0. And it's very important that we do this because when we actually go to determining all the zeros of the polynomial, you're going to have to do synthetic division, so this will be a good practice. Alright, so I'm going to use synthetic division. I'm going to use the number 1 first. So it looks like that's a 0. So synthetic division, you remember, we put our 0 here. We list our coefficients. This is 6x cubed. Remember, there is no x squared term, but I need a placeholder. And then negative 5x, and then negative 1. Alright, and then we bring that down and we do our synthetic division. So 1 times 6 is 6, and add 6, and add, multiply, and add. I do get a remainder of 0, so the number 1 is a rational 0. So that actually is a rational 0. Okay, so the number 1 is a rational 0. The only question is negative 1/3 also. So now I'm going to synthetically divide by negative 1/3. Now you do not go back up and rewrite the coefficients to determine the next one. You just simply divide what you have here, this list of numbers, using the next 0. Do not go back to the beginning. And again, you're not going to want to do that when you actually go to determine all these zeros in the next lessons. Otherwise, you're going to have problems. All right, so we'll bring the 6 down and we'll do the same thing. So negative 1/3 of 6 is negative 2. That's a 4. This is negative 4/3. Now, this is not going to subtract equal 0. So negative 1/3 is not a rational 0. So the only rational 0 that we have out of our list is the number 1, which means these other two are irrational zeros. Okay, and we'll talk about those in another lesson. All right? So that's how you're going to use your calculator to help you go from having a list of potential zeros to actually determining which the zeros are. Okay, in our second example, we have the graph here, and again, I've graphed 2x cubed minus x squared minus 9x plus 9, and I have listed my potential zeros here. Now this number here, this where it crosses or touches, appears to be negative 1, 2 1/3. That's negative, I don't know, 2, 4 something, 6/2. That doesn't really look like it's halfway in between anything, so none of these halves, it doesn't look like it falls on anything, so that doesn't really look like it's going to be a 0 in my list. This place here, now this looks like it crosses maybe at maybe 1 1/2, so maybe it looks like positive 3/2 could be a 0. It doesn't look like 1/2 is in my list. 3/2 looks like it is in my list. 9/2, which is 4 1/2 out here. So the only one that looks like it might be a 0 is 3/2. So I'm going to use synthetic division to actually see if that is. So we're going to divide by 3/2. That's my potential 0. And so I'm going to use 2, and then negative 1, and then negative 9, and then 9. So this is a 3, 2, 1, 0. So I have all my placeholders. And we'll do this. All right. So 3/2, do it down here so you kind of see, times 2 gives me a 3. So that's going to give me a 2. So this is going to be the same thing, a 3. This is negative 6. So negative 6 times 3/2. So that's 3. That's going to be negative 9. So when I do my synthetic division using 3/2, the number 3/2 actually does end up being a rational 0. So 3/2 out of my list is the only one that ends up being a rational 0.